Hello everyone, it is January 22nd and it is a perfect time to do LeetCode problem 1669, merge in between linked lists. You're given two linked lists, list 1 and list 2 of sizes n and m respectively. Remove list 1's nodes from the 8th node to the bth node and put list 2 in its place. The blue edges and nodes in the following figure indicate the result. So we want to remove the nodes inclusive from A to B. So in example 1, we're given list 1 and they want us to remove at index 3 to index 4 inclusive, remove these two nodes, and then node 13 points at the beginning, the head node of list 2, and then the tail node of list 2 points at the node immediately after b equals to 4. So it looks like we'll have to traverse through list 1 up until the point where we get past a minus 1 nodes, which is 2, not including the root node. So we move 1 node, we move 2 nodes. A minus 1 nodes would be the node we need to remove. And then we need to point this node at this node. But before we remove the next node from 13 to 6, we still need to traverse all the way until after node 9 in order to reach node 5, since we will be using that later. So I'll need to keep track of this node, and then I can change its pointer, and then I'll have a copy node that is initially this node, and well, let me see. And then before I change the next pointer, I'll traverse through here and get this pointer and store it. And then I'll start setting the next pointers over. Okay. So we continue traversing until A is equal to 1 then. Okay. While A does not equal to 1, well, what if it equals to 1? If it equals to 1, then that's still fine, because the root node based off of based off of these constraints, the root node cannot be a node we remove. So while A does not equal to 1, I want to set actually the head equal to n, I'll say list 1 head equals to list 1. List 1 cur equals to list 1. Okay. While A does not equal to 1, it initially will be 3. So we'll move the node over list 1 cur equals list 1 cur dot next. Now it's at the node 1. A minus equals to 1. We move over to the 13. A minus equals to 1, and now A will equal to 1. So we no longer traverse So then we need to store the node that we're on so that we could then keep traversing through until we reach 5. And that way we can then have something to point at once we traverse through list 2. So I'll write cur tail equals to list1 cur, which represents node 13. And then while b does not equal to 1, and b should also be decremented so that once b equals to 1, I'll have gotten to node 9, and then I can store node 5. List1 cur equals list1 cur dot next, b minus equals to 1. And now I'll store that node. I'll store node 5 as list1 tail equals to list1 cur dot next. List1 cur is this node, and we're storing this node. Okay? And now, and I'm going to change this to say list1 current tail is node 13. List1 cur tail equals to list 2. So the node 13 is now pointing at this node. And now we need to traverse through that linked list. So while list1 cur tail dot next, wait a second, list1 tail equals list 2. That's not right. So this will be the 5. And then this is the 13. We're traversing through list1 cur to get the 5. So list1 cur tail dot next equals to list 2. Okay. While list2 dot next, list2 equals to list2 dot next, going from this pointer to this pointer, and then this pointer to this pointer, and there isn't a next node. So then we set list2 dot next equal to list1 dot tail, setting this node's next pointer to 5. And then we return list1. Okay, let us run this back then. Sure, that's fine. Okay, list1 cur equals to list1. That's this node. While a does not equal to 1, we will traverse to the next node, subtract this to 2, subtract this by 1, excuse me, move 1 over, this changes to 1, this changes to 2. A does equal to 1, so we don't enter this loop. List1 curtail is now node 13. Okay. And then we need to continue traversing. Let's see. All right, LCT, list1 curtail. And then we need to continue traversing to get node 5. So while b does not equal to 1, is that right? List cur equals list cur dot next. B is now 1. It's actually while b does not equal to 0. Move this one more time. Now b equals to 0. Okay, and now list1 tail equals to this node, list1 cur's next node, list1 tail. Okay, and now I need to set list cur tail, this next pointer, this node's next pointer to this node. So list1 tail equals to list1 curtail dot next equals to list2, the head of this node. And then we begin traversing this node while the list1 dot next exists. We traverse one over, and now this doesn't have a next node. So we set this next node, list2 next node, to list1 tail, and then we return list1. That all looks good to me. Okay, I'm gonna run it. Yeah, list1.tail is not, I shouldn't have said that. What is it then? List2.next equals to list1 underscore tail. Okay, fantastic. Memory is not great. Pretty fast though. One thing that I could see kind of tripping me up though is the naming convention. What would be an appropriate name though for this node and storing this node? This is the tail realistically of list1. So what could I have named that? List1 cur. That's fine. Excuse me. Yeah, I think that's fine. Let me see. Okay, I'm gonna enter this in now to ChatGPT and see what they think. Mutating A and B. Yeah, I can see that. I mean, the consistency between while A does not equal to 1, while B does not equal to 0, I can see how that would be just a little bit confusing. Interviewers preferred fixed inputs and explicit counters. Before A, after A. Ah, yes. Yeah. That's better. Okay. I'm gonna start doing this now for sure, traversing through the linked lists a certain amount of indices or a certain amount of through a certain amount of nodes. This is a lot nicer. B minus A plus 1. And you know, just writing the notes like that, the steps, it's just so much cleaner too. I find the node before A, the node after B, and splice list 2 between them. I find the node A and the node after B in list 1 and splice list 2 between them, and then by setting the tail of list 2, by setting the next pointer. See, you know what? By setting the tail node's next pointer of list 2 to the node after B. Yeah. I don't like to do word vomit, but yeah, I mean, part of it is not just writing the code, but making it clean, being able to explain it well. Well, thank you all for joining me. I hope you're having a fantastic night and that your interview prep or whatever you have going on is going amazing. Thank you and take care.